Hi guys, welcome to Calculus Crush. Today we're going to be deriving the quotient rule of calculus. If y is equal to the division of two functions, or the quotient of two functions, say f of x divided by g of x, then its derivative, y prime of x, is equal to f prime of x times g of x minus f of x times g prime of x, all divided by g squared of x. So that's the quotient rule. What we're going to do is we're going to derive that using the definition of the derivative. So to begin, we need to write down the definition of the derivative, which is y prime of x is the limit as h approaches 0, y of x plus h minus y of x divided by h. So this is the definition of the derivative. If you don't know where this comes from, you can click on this equation here and it will take you to another video where I derive this definition using the slope of the tangent line and limits. Okay, so now let's substitute in what y is. So y is equal to f of x over g of x. So we have the limit as h goes to 0. So y of x plus h will just be f of x plus h divided by g of x plus h minus y of x, which is just f of x divided by g of x. And this whole thing is divided by h. The next step, we need to subtract these two fractions. In order to do that, we need to have a common denominator. And that common denominator is just the product of these two denominators. So I'm going to write that down here at the bottom. G of x times g of x plus h times h. We still have that h there. And on top we have the first term is now g of x times f of x plus h minus g of x plus h times f of x. That's the second term. There's not much we can do with this expression on its own. What we need to do is add and subtract an expression so that we don't actually change the numerator, but we can use it to do some factoring and do some simplification. So we have g of x times f of x plus h. Now I'm going to write two new factors, minus f of x times g of x. And if I subtract that, I need to plus it. And then our last term, which is g of x plus h times f of x. So I forgot the brackets up here. And this is divided by g of x times g of x plus h times h. So this term here, including the minus sign, that's new. That's something we added to the equation. But if you actually add these two terms together, you just get 0. So we haven't changed the equation. We haven't changed the expression. All we've done is just add a couple of terms. And we'll see why. This is a little trick we use. So now these two terms here, I'm going to put them together. And these two terms here, I'm going to put them together. So what's common between these two terms? Well, this is g of x. So we've got g of x times, then in brackets, f of x plus h minus f of x. And this is all divided by g of x times g of x plus h times h. Now for this second term in blue, I'm going to factor out an f of x, which is common between them, plus f of x, and we have g of x minus g of x plus h. And on the bottom here, we've got the same thing, g of x times g of x plus h times h. Okay, so I need big brackets around everything because we have to take the limit of all that. Now what I'm going to do is I'm going to distribute this limit to each term. So what we get is, actually I can do it one more line down here. The limit as h goes to 0 of g of x times g of x plus h and g of x on top times the limit as h goes to 0 f of x plus h minus f of x all divided by h. Now I'm going to put a minus sign here. And I'm actually going to switch this g of x plus h and the g of x around. We'll pull out a minus sign. We have the limit as h goes to 0. So on the bottom we've got g of x times g of x plus h. And on the top we've got f of x times the limit as h goes to 0. G of x plus h minus g of x all divided by h. Okay, what we can see here is this term is actually just the definition of the derivative for f of x. It's just f prime of x. This term here, this is just the definition of the derivative for g of x. So it's g prime of x. Then all we have to do is sort out these terms here. Well, we can cancel out these g of x's. And then what we end up with is just a 1 over g of x here. So we'll write it up here. We have 1 over g of x times f prime of x minus, now this will be f of x over, so this h goes to 0 and we just have g of x squared. And then we have g prime of x here. So now we have two fractions. If we want to add them together, we need a common denominator. So we just need to times this term by g of x over g of x. So what we get is g of x times f prime of x minus f of x times g prime of x. And that's all divided by g of x squared. You can also write it as g squared x. It doesn't matter. So this is almost exactly the same as what we have here. We just need to rearrange the terms and we get our final expression. So I just put the f prime of x first, then the g of x minus f of x times g prime of x. And that's divided by, I'll write it this way, g squared x. So y prime of x. And this is how I read it. I like to read it as the derivative of the top times the bottom minus the top times the derivative of the bottom, all divided by the bottom squared. So there you have it. That's the derivation of the quotient rule. Now you know where it comes from. If you have any questions, just leave them in the comments. Please subscribe. Thanks a lot, you guys. Until next time.